Today's topic is decoding of cyclic code. So we already studied how we can encode a cyclic code. So next we can see decoding of cyclic code. So this decoding of cyclic code have two parts. First one is error detection. After that error correction. So for error detection it use syndrome calculation. So we can see how the syndrome calculation possible in cyclic code. So for that we are taking V as code vector transmitted over a noisy channel and Z as the received vector after coming this noisy channel. So this Z may be same as that of V or may not be. So we need to find whether this Z is correct or not. So decoder will find the transmit code vector based on the received vector, and this decoder first calculates syndrome of the received vector to identify whether it is correct or not. If syndrome 0, we can say that this the received code vector is valid. That means the received code vector is same as that of transmitted code vector, or we can say that the received vector polynomial is divisible by generator polynomial and received vector is valid if syndrome is 0. If syndrome not equal to 0 means transmission error happens. So we can see how it is this decoder will check that. So we can see that our first this received code vector is divided with the generator polynomial. So the transmitter and the receiver have same generator polynomial. So to find this syndrome and to find whether it is error or not, this received code vector is divided with the generator polynomial. So you will get the result as well as a remainder. So we can write it as this z of x by g of x equal to q of x plus s of x by g of x, where q of x is the result of that division and s of x is the remainder of that division. So we can say that this s of x represent the syndrome of syndrome of our received vector. So when we divide this received vector with the generator polynomial, the remainder will be the syndrome vector. Say that this q of x is the quotient polynomial of the division and s of s is the syndrome of degree, and its degree is n minus k minus 1 or less. So we can say that this received code vector is transmitted code vector plus error. So this e of x equal to error pattern. So this now if the syndrome is not equal to 0, then the received code vector happens some errors. So we can say that this received code vector is this transmitted code vector plus error. So that we can replace this z of x by g of x, we can write as v of x plus e of x all divided by g of x all divided by g of x means v of x by g of x plus e of x by g of x. But we know that this valid code vector is the multiplication of message vector into generator polynomial, that is v of x equal to d of x into g of x. This d of x is the message polynomial. So we can replace this v of x as d of x into g of x. So d of x cancel, remaining is d of x plus e of x by g of x. That is our second equation. So we can see that we can combine this equation 1 and 2. So our equation 1 is, we can see that our equation 1 is z of x by g of x equal to q of x plus s of x by g of x, and our equation 2 is z of x by g of x equal to d of x plus e of x by g of x. So we will get it as d of x plus e of x by g of x equal to q of x plus s of x by g of x. In that we can find what is e of x by g of x, which is nothing but q of x plus d of x plus s of x by g of x. Here we are using modulo to addition. In linear block code as well as in cyclic code, we are using modulo to addition. So this minus d of x is same as that of plus d of x. So from this we will get the error as g of x into q of x plus d of x plus x of x. So we can say that syndrome of z of x is equal to remainder resulting from dividing the error pattern by generator polynomial. So if we are dividing the error pattern with the generator polynomial, then the syndrome is equal to the remainder resulting from this error pattern divided by e of x. So g of x. So we can say that this error pattern by generator polynomial. So we can say the syndrome contain information about error pattern that can be used for error correction. That means if we are divided with the received polynomial with the generator polynomial, then if you have some remainder, then it means that there should be some error. So this syndrome pattern is used for error correction. So next we can see how we can draw the syndrome calculation circuit. So this is our syndrome calculation circuit. So the only difference is that in case of encoder circuit, we are providing the input from right side. Here we are providing the input from left side. Here the input is received vector. So we can see how this syndrome procedure, how to calculate this syndrome. So we can see the procedure. First we need to initialize all the registers. That means we need to clear the content of this flip-flops. This S0, S1, Sn minus k minus 1, all the things are all are flip-flops. So we need to initialize the flip-flop first. Then first we need to on this gate 2 and gate 1 is in off condition. So received vector z entered into the shift register. So then this all the received vector will enter into this shift register. Then after enter received vector is shifted into the register, content of the register will be syndrome. So after getting this received vector, this circuit will calculate the syndrome bit. This S1, 0, S1 up to Sn minus k minus 1 represent the syndrome bit. So it's a division circuit. That means this is z of x divided by g of x that will do this circuit. So that is basically a division circuit. Then after this we will off this gate 2. Then this gate 2 becomes off and gate 1 becomes on. Then we will get the syndrome syndrome vector S is shifted out of the register. Syndrome not equal to 0 means error happened. So that's where this error dictation is possible in a cyclic code. So for error dictation we are using syndrome calculation. So this is the error dictation. So next we get the function of this decoder is to find the error, do the error correction. So that decoder is called as decoder of for n by k cyclic code is also known as Megit decoder. So this is the structure of this Megit. So in this Megit decoder circuit, first the received vector is fed into the buffer register as well as the syndrome register. So the syndrome register is used to calculate the syndrome vectors. So first we shift this received vector into buffer register as well as the syndrome register. So this obtained received vector, using the obtained received vector, so the syndrome register calculate this syndrome. If the syndrome is 0 means there is no error, and if the syndrome is not equal to 0 means there is an error. So this error pattern dictator output becomes output will be 1 if there is an error. So that if the error pattern dictator output is 1 means there is an error, and that means the rightmost digit of this buffer register content is error. So that will be corrected. That means if the rightmost buffer register content is 1, then that becomes 0 if the error pattern dictator is 1 at that time. So then the next step, this error pattern dictator output is fed to this syndrome register. At the same time, this buffer register content will shift right one place, and the syndrome register content also shift right by one place. Then using the new content of the syndrome register, again new syndrome calculated. If that new, based on that new syndrome, this error pattern dictator's output may be 0 or 1. 0 means there is no error, 1 means there is an error. That means the second digit of this buffer register content. That means now this buffer register content, now the rightmost bit of this buffer register content, that is the second digit of the received vector, should be error. So that will be corrected based on that. So this way all the digits will check, and finally we will get the corrected vector. So and finally we can see that after correcting all the errors, finally the syndrome register content should be 0. If it is not 0 means there is an undictatable error pattern. So this way we can find the error correction. So we can see in detail. So decoder has to find a correctable error pattern E of x from the syndrome S of x and add E of x to Z of x to find the transmitted chord vector V of x. So we already studied that this correct chord vector is the modulo 2 addition of received chord vector plus the error vector. So this error vector is obtained by using the syndrome vector S of x. So we can see the procedure of this Megit decoder. First we said received vector is shifted into the buffer register and syndrome register. So the received vector is shifted into buffer register as well as this syndrome register. Then syndrome register contains syndrome for the received vector. So that syndrome register calculate the syndrome. If the dictator reads syndrome register content, dictator output equal to 1 means received digit at the rightmost stage of buffer register is in error stage and should be corrected. So after finding the syndrome, this error pattern dictator will read whether it is 1 or not. If it is 1 means rightmost bit of this buffer register content is in error stage. So that will be corrected. If dictator output equal to 0 means the received digit at the rightmost stage of the buffer register is assumed to be correct. So this way we can check that first bit. Then so dictator output is estimated error value for digit coming out of the buffer register. So the first digit, first buffer register content digit error pattern is calculated. Then in step 3 the first received digit is shifted out of the buffer register and at the same time the syndrome register is shifted right once. So after this error correction of the first digit at the rightmost place, this buffer register content shifted right by 1 place, and similarly the syndrome register content also shifted right by 1 place. Then this error pattern dictator output is also fed to the syndrome register. Then using that it will calculate this new syndrome. So we can see the step. So this the syndrome register is shifted right once. If the first received digit is in error, dictator output equal to 1, which is used for correcting the first received digit. The output of the dictator is also fed into the syndrome register to modify the syndrome. This results in a new syndrome corresponding to the altered received vector shifted to the right by 1 place. So then finding the new syndrome, then it is used to check whether or not the second received digit at the rightmost stage of the buffer register is in error state or not. If so, it is corrected. Then again a new syndrome is calculated as in step 3 and procedure is repeated for all the digits, all the received digits. So the decoder operates on the received vector digit by digit until the entire received vector is shifted out of the buffer. So this way this error detection and error correction is possible using this Megit decoder. And one more thing, at the end of the operation, that is after the received vector is shifted out of the buffer, error will have been corrected, all the error will have been corrected and syndrome register contains all zeros. So if all the errors corrected means then the syndrome, final syndrome should be 0. If syndrome register doesn't contain all zeros after shifting all the received vectors out from this buffer register, then also the register content of syndrome is not all equal to 0. Then an uncorrectable error pattern has been detected. So we can say that there is an uncorrectable error pattern. So this way we can check the error as well as correct the error using this Megit circuit. So what is the decoder of cyclic code? N by K cyclic code means that is the Megit decoder.